Hi there! I'm glad to see you here. At this level, you will be a Formula 1 racer with the objective of describing uniformly accelerated motion in the horizontal dimension, qualitatively and quantitatively. Each pit stop is full of comprehensive discussions, simulations, and a game you will surely enjoy. So put your seatbelt on and enjoy the ride. Before we proceed with our main lesson about uniformly accelerated motion, let us have first a brief recall about acceleration. We say that acceleration is a change in velocity per unit time, meaning a body is accelerating if there is a change in speed, direction, or both. Now, consider the motion of a car as shown in the diagram. We can say that the car started from rest at 0 seconds. After 1 second, its velocity is 5 meters per second. 10 meters per second after 2 seconds, and 3 seconds, it is now 15 meters per second. Based on this data, it is evident that for every time interval, the car is increasing or changing its velocity, which is equal to 5 meters per second. And since the car has a constant change in velocity, it also means that it is accelerating. Using the formula for acceleration, we can compute its magnitude for every time interval. Acceleration equals final velocity minus initial velocity divided by time. This will give us a constant value of 5 meters per second squared. With this, we say that an object that has a constant change in its velocity also has a constant acceleration. Uniformly accelerated motion. So the car in our previous example is exhibiting uniformly accelerated motion in the horizontal dimension. In solving problems related to uniformly accelerated motion, we can use the kinematic equations. Let's apply these equations by solving this sample problem. How long will two race cars cover a 600-meter straight track if one accelerates from rest at 3 meters per second squared and the other at 3.5 meters per second squared? To solve this, let's first determine the given values from the problem. Since both cars started from rest, then their initial velocity is 0 meters per second. They also covered the same total distance of 600 meters. Car A has an acceleration of 3 meters per second squared and 3.5 meters per second squared for car B. To compute the time t it took for each car to cover the track, we use distance equals initial velocity times time plus 1/2 acceleration times time squared. For car A, the time is 20 seconds, and for car B, time is 18.52 seconds. So what does this imply? Of course, in a race, the main objectives of the competitors is to win. That is, covering the same distance for a shorter period of time. And you can only do this if you can maintain a higher constant acceleration. Well, that's the science behind winning the Formula 1 race. Quite easy, right? If you want to learn more about deriving kinematic equations, or if you feel like engaging in more problem-solving experiences, you can check out the different learning resources here at PHYQUEST and immerse yourself in the amazing world of physics. See you in the next level!